Bismillahirrahmanirrahim. Assalamu alaikum. It's our 28th lecture of Advanced Electromagnetic Field and Waves. We are already started chapter number 10 of our book Jackson, and today we will do some shortcomings, some basics, discuss about some basics of these chapters. Okay, if we already started this chapter, if you don't watch those videos, scattering videos, you can watch. Okay, today's video is just for introductory video for this chapter. Okay, basically we are starting chapter number 10 of book Jackson, which is diffraction and scattering. Okay, you know that there are two types of things like electromagnetic wave has to come and they have to be strike on some obstacle. So if your electromagnetic wave strikes some obstacle, so definitely if light wave, electromagnetic wave, it's a light wave, so definitely your light will bend. Either it will diffract or either it will be scattered. So these two phenomena should happen one after your electromagnetic wave strikes the obstacle. Okay. So there are three types of scattering basically we are discussing about. First is the Rayleigh scattering. What is basically the Rayleigh scattering? In Rayleigh scattering, basically when your wavelength is large than size, obstacle size, means your wavelength is large. Okay, if your wavelength is large than size, which size? Obstacle size. If your obstacle is small in size, while your incoming electromagnetic wave has greater wavelength, then this type of scattering would happen, which is so called as the Rayleigh scattering. Okay, this mainly happens in our sky. You can see our sky blue due to this phenomena, Rayleigh scattering. Okay, molecules in atmosphere. Next scattering is basically the Mike scattering. What is Mike scattering? When the wavelength is very small as compared to the obstacle size. Okay, the obstacle size should be large and your wavelength of incoming EM radiation is small, then you can say this is mic scattering. And while appearance in cloud, you can see how clouds appear white. The phenomena is due to the mic scattering. And third one is the most common, that is the Raman scattering. So what is basically scattering and diffraction? The basics, that in reflection incident wave must be equals to the reflected wave. This is, that this is the law of reflection. Another phenomena is, that is refraction. When your light is bent towards normal, incident not equals to the reflected. Okay, and third phenomena is scattering, and fourth phenomena is diffraction, which we are concerned in this chapter. So let's check the dependence. Like you can let's suppose we have one medium here, and this is our second medium. The first medium has permittivity E1 epsilon 1 and permeability mu 1. The second medium has permittivity epsilon 2 and permeability mu 2. Let's suppose the even epsilon 1 value is 2, mu 1 value is 4, epsilon 2 value is 4, and epsilon mu 2 value is 8. Means medium 2 is double of the medium 1. You can see 2 becomes 4 and 4 becomes 8. Medium 1 is exactly double of the medium 2. Medium 2 is exactly double to the medium 1, sorry. Okay. So what if you want to find the impedance of medium 1 and medium 2? You know that impedance formula is Z equals to mu naught by epsilon under root mu 1 mu naught by epsilon naught. So mu 1 value is this, which is 4 divided by 2, you get under root 2. But what you can see here when you solve for medium 2, which has greater double uh, uh, values than medium 1, you can say it is the same medium. Okay, so if your impedance match, if your impedance is same, then there is no reflection, only there is transmission. So in order to light reflect, incident must be equals to reflected, light should reflect. There is some difference in the impedance. Let's suppose this is air and this is glass and this is water. If both mediums have same impedance, then there is no reflection. Light would not reflect back. There is only transmission. Light will transmit it, penetrate into. Okay. Okay, now let's move towards the constitutive parameters. The constitutive parameters are these. You already know this is the epsilon, which is the electric response, and this is the mu, which is the magnetic response, and this is another factor sigma. You know that d equals to mu epsilon e, whereas b equals to mu naught h, whereas your current j now equals to sigma e. Okay, these are the constitutive parameters. So there are some points relevant to these constitutive parameters. So the point is simple. First, you have, let's suppose, what is isotropic medium? What is isotropic medium? So the simplest possible medium are scalar. Okay, if your epsilon, mu, and sigma are scalars, then you can say that your medium is isotropic medium. Okay, when your epsilon, mu, and sigma are what? Scalars, then these are the isotropic mediums. If your values, constitutive parameters, are a function of frequency, then you can say this is dispersive medium. Okay? Whenever frequency is a concern with your constitutive parameters, you can say this is a dispersion relation, or you can say this medium is the dispersion medium. Similarly, electric field point to point change with respect to position. What it means? It means if your constitutive parameters are function of positions, means time to time positions varies. So then you can say that this is inhomogeneous medium. But if your constitutive parameters are not function of positions, you can say this is homogeneous medium. And if they are not function of frequencies, then you can say non-dispersive mediums. Okay, so what we conclude is that only thing is if they are scalar, then you can say these are isotropic medium. If they are frequency dependence, they are dispersion medium, sorry, dispersive medium. If they are position dependence, then they are inhomogeneous, and if they are position depend not dependence, then they are homogeneous medium. And if they are not depend on the frequency, then they are the non-dispersive medium. Understood? So in general, we can say our constitutive parameters are not scalar, they are tensors. What are tensor? Basically, let's suppose there are many forces are applying. Like this is your cylinder. Let's suppose you have a cylinder, and when you apply a force from upside, what you can see here is that a stress is applied to the corners of the cylinder. So more directions stress than need tensor. Okay, when there are more directions, okay, then you have to solve the parameter by using the tensors. Okay, so these are called as the tensors, and in case of tensors, your constitutive parameters are just replaced by these, where d equals to epsilon double bar e, b equals to mu double bar h, and j equals to sigma double bar e. Okay, and you can rewrite the tensors in matrix form like this. Let's suppose you are writing tensor form of this. This becomes e12 e11 e12 e13 e21 e31 e22 e32 e23 and e33, and e is as it is. Similarly, you can write for this for mu, and similarly you can write for sigma. Okay, so this is how you can represent in form of tensor. Now basically you can see tensor is the transformation, you can transform. Okay, what is now see the relationship of permittivity and permeability. If permittivity and permeability both negative, when they are negative, when they are smaller than 0, then your reflective index is also negative and light bend towards normal. Okay, and this scenario is called as the left-handed material, and those materials are called as the metamaterials. Okay, when when your permittivity and your permeability is greater than 0 means they are minus, then their reflective index is also minus, means that they will bend towards normal, and those materials are the left-handed materials, and those are called as the metamaterials. Okay, similarly when your epsilon naught and mu naught is equals to 0 means your permittivity as well as your permeability is 0, then what would happen, this type scenario is called as the nihility material. Okay, nihility material. And when both are 0 and your phase velocity is negative, then these are called as the L-nihility medium. These are 0, that's why they are called as the nihility. But when they are 0 and in addition their phase velocity is negative, they are known as the L-nihility medium. Okay, so if both are not 0, if both are available, okay, so you can just add. So let's suppose if both electric and magnetic response, so you have to add. So you have to add in term of D and you have to add in term of B. So you know that electric response is this epsilon E, and magnetic is mu H, and in form of B you can write it as sum of this. Okay, but when you add, when both are present, okay, and if these epsilon and mu both are scalar, then you can say, because these are the two constitutive parameters, these are two, that's why you can say by, because these are two parameters and these are two constitutive parameters. If those constitutive parameters are scalar, we already discussed they are scalar and in general they are tensors, but when if they are scalars they are known as the bi-isotropic medium. Okay, and when they are tensors they are known as the by anisotropic medium. You already discussed here is that when the constitutive parameters are scalar, then these are called the isotropic mediums, because here both are two constitutive parameters, that's why they are called as the bi-isotropic medium. But if they are tensors, what we discussed is here, those are called as the by anisotropic medium. Okay, an example of these are the chiral mediums. Okay, and these are basically used for polarization rotate. If you want to rotate the polarization, you can use these tensors. What it means, if you want to convert perpendicular polarization to parallel polarization or random polarization to linear polarization, you can use these types of fields, okay, by using these tensors relation. So that's all for today's lecture. In upcoming lecture we will have to upload more interesting videos relevant to this course. Till then, take care and Allah Hafiz.